Hi and welcome back to the lab. And today here on the bench we have a Kenwood TS-850. And the 850 is here for the Mars modification. And that is due to the fact that the old man wants to work on 60 meter, which has been opened in 2015 or 2016, I believe. So that is 5.3 megahertz, and the older radios like the TS-850 has not 60 meter open. So therefore we are going to perform the mass modification to be able to use these frequencies. And secondly, the radio is here for preventive maintenance, so we know that this radio is suffering from some leaking electrolytic SMD capacitors, especially on the local board, and there is another capacitor on the audio board, and two capacitors, I believe, on the display board. So that is really a tough job, because it is a lot of work to do. And on the other hand, we know that we have different degrees on damage on especially the local board and the display board. So we really have seen that the acid nearly everything destroyed on the PCB. So that means we really have to see what the status is, and well, then we can decide what we really can do. So for now the radio is working, so that is what the operator was telling us. So it is working, and it has never been repaired so far, and it was bought in 1993, I believe. So he bought it, and it was always in his hands. So let's see what we can do, and let's hope that you know, this electrolytic problem is not that bad as we have seen it much too often. So let's go into the work and let's see what we can do. Right, let's go into the video. So you see our unit is receiving, so that is good. And I've set it to FM to check if it is transmitting, and yes, it is. So both is given. I do not go deeper into checking all the different functionalities. So it's fine to see that it is basically fine. Now let's directly crack it open. Okay, and we are in. Everything looks quite nice on the first glance. Now let's open here our local board to see how it looks like, and then let's go through step by step. We find the local board in a really good shape, so maybe that is really a later batch. What we see here, we have all these little caps which are known for leaking, but everything is nice. But to be sure that it will last for longer, we're gonna swap them all out, especially here our 47 microfarad capacitor, which is really the most worst one. But anyways, it is still fine, so we do not have any damage on the board, which is perfect. Alright, so as you can see, I have already replaced here the first one, and that is a tantalum capacitor. So same values, 10 microfarad and 16 volt. So that is what I've here, 16 volt, 10 microfarad. So that is what we gonna put into it, and then all the old and well, not really good electrolytic capacitors are gone. Okay, and as we can see, we have fitted in all the new capacitors as discussed earlier, and I've put here as well a tantalum capacitor in. So you see that board is ready to go, and let's put it back into the radio. And as you see, we are moving already further. So here under our filter board, our transmitter filter board, we find of course our power amplifier board. That is fine, but that is not what we are really looking for. If we go down there, hope you can see it, we have here our first power supply board. So you see here our power input from our external power supply, and here we have the first filtering and so forth, and we need to swap out here some capacitors in order to maintain a really low noise floor. So that is important for our digital board, because if the digital board will not get a nicely filtered DC, then it starts making funny things. So we go and swap those capacitors out. And here you see I have the board out, and here you see the Bose filter caps, which we swap out now in order to maintain our low noise. Okay, so our new capacitors are in, and important was to swap out the old one because they also were only where can we read it, 85 degree C capacitors, which is a kind of funny here in this environment, since we have here our power amplifier, which is getting hot, and above our power amplifier and here our voltage or supply board, however you want to call it, we have our filter board, and that means we really have here a tough environment for caps. Right, so that is done, and we go ahead. Right, we are now down at the IF board, which is here the right board, and there we need to swap out these Bose capacitors, which are related to our audio circuit, which is here on the board as well, and that needs to be swapped out, as they are known for making trouble. But well, still it looks pretty nice. I've seen boards where you already can see here the asset on the board, but we don't see that here. But just in case, to be sure that it will be fine for a longer time, we go and swap this Bose known caps out as well. Now that needs to be a little bit more work. As you see, we really need to lift up the board to get underneath. So okay, let's start. Now the board is out, and I have now directly access to our Bose capacitors, which are here, this Bose capacitors here, which we need to take out. Alright, and as you can see, we have here our new two capacitors in, and now we have to move to our display board and to our control unit. And because we need to swap out two or one capacitor on our display board, we have the front open, and we have access to our, which is down here of course. Then we have access to our control board or processor board or whatever, and there we can then perform our mask modification, and then we should be done. Right, so here we have our display board, which is this one here, and this is our processor or a logic board or whatever. And first let's take out here our display board in order to get to this capacitor, which is always leaking, and let's swap it out. Okay, and the screws are out, and now I can lift here out the board and flip it over, and this here is a capacitor which is always making trouble, and this one here, as you can see, it looks like new, but I've often thought that there is definitely not a problem, but when I then lifted the capacitor, I saw very often that the acid is already underneath. I mean, it could be fine here, but who knows? So the best is to lift it off and see what we can do. And I mean, it is, can we read it? Maybe not really, but it is a Nichicon capacitor, which is very odd that especially this capacitor here is always leaking. So we do not have another chance to check it out, and if it is fine, okay, no problem. But what is if there is already something damaged underneath? So let's go. Alright, so here is the board, and the capacitor is out, and yeah, on the first look you think everything is fine. And as well, if I'm looking here at our capacitor, once again it is a Nichicon, you do not see really that it is going bad. Test it on the capacitor tester, it is fine, so you cannot see a problem with this capacitor. But let's see the whole thing under the microscope. Okay, so even through the camera it is not easy, but what we can clearly see, we have already acid here on the board, and we see here on the left hand side that the copper gets eaten away, so that is only the starting. We see it here as well, and in the middle here you see that there is something on the board, and that is acid. You see, I can get it off here a little bit, so that is already acid, and that is how it starts. And the next what happens is that this trace here gets cut off, right? And you see it is liquid here, so that is already acid. And the next is that this trace get cut off, and then in that moment you have no display any longer, no display backlight any longer. And I mean, then you can take it off and you replace it, no big damage. If you are unlucky, it is eaten away here, this trace here, and it takes really a long time until the backlight gets off. But then you have a huge damage on the board, and here it is definitely the right moment to do this. So now I can clean it, we replace the new capacitor in, and everything is fine. So let's go ahead. Alright, so our new capacitor is in, so of course I can now lift here or put the board back, connect everything, and then left is our mask cap. Right, let's check. Okay, so after all our maintenance, the radio still works. That is good. Now left is our, not Mars cap, Mars modification, of course, to get open our 60-meter band, and yeah, so that is now the last thing we have to do. I've already dialed in the 60-meter band, and as you can hear, of course, we can receive, so that is no problem. But when I try to transmit, you see these frequencies are blocked, and I'm not able to go on air. So therefore we need our modification. Here on our controller unit we have here a diode matrix, which is used that the radios can be programmed to the different zones on Earth. So you know, there are differences in frequencies, and therefore we have always a kind of matrix where it can be programmed to the dedicated countries. And of course this is now for us a point where we need to do our changes, and in this case, so you see that here is our diode matrix, and here it is quite easy. First of all, we cut this what is it, D11, in order to get full band transmit. Okay, and that is quite simple, to be honest, because simply we go down here with a little cutter to the wire. So my only challenge is to do it behind the camera. Okay, then cut, and it is already done. Now I bend it a little bit away. Let's see, like so, that there will definitely no contact possible. And the beauty here is that if for any reason you need to bring it back to a factory, you simply can solder it back together. So that is definitely no big deal here. So let's try if it worked. Okay, radio is already receiving. Now let me press here PTT. And you see it is displaying on air, but that does not tell if we have really output power. So therefore let me switch here over to my LP500, and now let's go over that. Can we see both? I don't know, maybe. It is not a clear picture, I believe. Okay, maybe that way here. Now let's see if it works. 1 2 1 2 1 2. Hola! So you see we have output power. 1 2 1 2 1 2. But I can of course increase the output power. So let me do that. 1 2 1 2 1 2. Audio, audio. So you clearly see that we have output power, everything is working, and with this modification you can also tune the auto tuner, which is in here, to the new frequencies where you would like to work on. So therefore now it is working all band. Okay, so I guess we have really done everything we need. And of course I have now put back the housing and everything, that the radio is ready for pickoff. And yeah, that's it for the day. Hope it was a bit interesting to you and you learned something. Thanks for watching. Catch you next time. Bye.